U.S. Marines test defensive weapon system (DWS) machine gun fire on Osprey's MV-22 helicopters off the coast of Oahu, Hawaii, reports DefenseBlog. DWS is operated remotely and combines gunner station, targeting sensor and GAU-17 minigun weapon. The unique weapon is mounted in the Osprey's rear cargo hold and is operated via a remote control from inside the aircraft using an interface similar to video games. Parts of the defense weapon system equipped with flare systems and camera systems help the crew identify and determine targets at distances of hundreds of meters, even several thousand meters. DWS achieved the best firing radius by being installed outside the belly of the aircraft. Due to Osprey's unique ability to tilt the rotor forward for high-speed mode and again using a vertical system for helicopter landing. Before using a DWS weapon, Osprey used a single machine gun mounted on the back door, which limited the range of sight and the radius of the shooter's fire. The Bell Boeing V-22 Osprey is an American multi-mission, tilt-rotor military aircraft with both vertical takeoff and landing (VTOL) and short takeoff and landing (STOL) capabilities. It is designed to combine the functionality of a conventional helicopter with the long-range, high-speed cruise performance of a turboprop aircraft. The failure of Operation Eagle Claw during the Iran hostage crisis in 1980 underscored the requirement for a new long-range, high-speed, vertical takeoff aircraft for the United States Department of Defense. In response, the Joint Service Vertical Takeoff Landing Experimental JVX aircraft program started in 1981. A partnership between Bell Helicopter and Boeing Helicopters was awarded a development contract in 1983 for the V-22 tiltrotor aircraft. The Bell-Boeing team jointly produced the aircraft. The V-22 first flew in 1989, and began flight testing and design alterations. The complexity and difficulties of being the first tiltrotor for military service led to many years of development. The United States Marine Corps began crew training for the MV-22 Osprey in 2000, and fielded it in 2007. It supplemented and then replaced their Boeing Vertol CH-46C Knights. The U.S. Air Force fielded their version of the tiltrotor, CV-22B, in 2009. Since entering service with the U.S. Marine Corps and Air Force, the Osprey has been deployed in transportation and medevac operations over Iraq, Afghanistan, Libya, and Kuwait. The U.S. Navy planned to use the CMV-22B for carrier on-board delivery (COD) duties beginning in 2021. The Osprey is the world's first production tiltrotor aircraft with one 3-bladed rotor, turboprop engine, and transmission nacelle mounted on each wingtip. It is classified as a powered lift aircraft by the Federal Aviation Administration. For takeoff and landing, it typically operates as a helicopter with the nacelles vertical and rotors horizontal. Once airborne, the nacelles rotate forward 90 degrees in as little as 12 seconds for horizontal flight, converting the V-22 to a more fuel-efficient, higher-speed turboprop aircraft. STOL rolling takeoff and landing capability is achieved by having the nacelles tilted forward up to 45 degrees. Other orientations are possible. It has a ferry range of over 2,100 nmi. Its operational range is 1,100 nmi. Composite materials make up 43% of the airframe, and the rotor blades also use composites. For storage, the V-22's rotors fold in 90 seconds, and its wing rotates to align, front to back, with the fuselage. Due to the requirement for folding rotors, their 38-foot, 11.6 meters diameter is 5 feet, 1.5 meters less than optimal for vertical takeoff, resulting in high disk loading. Most missions use fixed-wing flight 75% or more of the time, reducing wear and tear and operational costs. This fixed-wing flight is higher than typical helicopter missions, allowing longer-range line-of-sight communications for improved command and control. Exhaust heat from the V-22's engines can potentially damage ships' flight decks and coatings. Naval Air Systems Command (NAVAIR) devised a temporary fix of portable heat shields placed under the engines, and determined that a long-term solution would require redesigning decks with heat-resistant coating, passive thermal barriers, and ship structure changes. The V-22 is equipped with a glass cockpit, which incorporates 4 multi-function displays (MFDs) compatible with night vision goggles, and one shared central display unit (CDU) to display various images including digimaps, imagery from the turreted forward-looking infrared system, primary flight instruments, navigation, TACAN, VORILS, GPS, and system status. The Flight Director Panel of the Cockpit Management System (CMS) allows for fully coupled autopilot functions that take the aircraft from forward flight into a 50 feet (15 meters) hover with no pilot interaction other than programming the system. The glass cockpit of the cancelled CH-46X was derived from the V-22. The fuselage is not pressurized, and personnel must wear onboard oxygen masks above 10,000 feet. The V-22 has triple redundant fly-by-wire flight control systems. These have computerized damage control to automatically isolate damaged areas. With the nacelles pointing straight up in conversion mode at 90 degrees, the flight computers command it to fly like a helicopter, cyclic forces being applied to a conventional swash plate at the rotor hub. With the nacelles in airplane mode, 0 degrees, the flaperons, rudder, and elevator fly similar to an airplane. This is a gradual transition, occurring over the nacelles' rotation range. The lower the nacelles, the greater effect of the airplane mode control surfaces. The nacelles can rotate past vertical to 97.5 degrees for rearward flight. The V-22 can use the 80 jump orientation with the nacelles at 80 degrees for takeoff to quickly achieve high altitude and speed. The controls automate to the extent that it can hover in low wind without hands on the controls. Some V-22 pilots claim that former fixed-wing pilots may be preferable over helicopter users as they are not trained to constantly adjust the controls in hover. The V-22 can be armed with one 7.62 x 51 mm NATO .308 in caliber M240 machine gun or .50 in caliber 12.7 mm M2 machine gun on the rear loading ramp. A 12.7 mm .50 in GAU 19.3 barrel Gatling gun mounted below the nose was studied. Base Systems developed a belly-mounted, remotely operated gun turret system, 128. The Interim Defense Weapon System, IDWS, it is remotely operated by a gunner. Targets are acquired via a separate pod using color television and forward-looking infrared imagery. The IDWS was installed on half of the V-22s deployed to Afghanistan in 2009. It found limited use due to its 800 pounds 360 kilograms weight and restrictive rules of engagement. There were 32 IDWSs available to the USMC in June 2012. V-22s often flew without it as the added weight reduced cargo capacity. The V-22's speed allows it to outrun conventional support helicopters. Thus, a self-defense capability was required on long-range independent operations. The infrared gun camera proved useful for reconnaissance and surveillance. Other weapons were studied to provide all-quadrant fire, including nose guns, door guns, and non-lethal countermeasures to work with the current ramp-mounted machine gun and the IDWS. In 2014, the USMC studied new weapons with all-axis, standoff, and precision capabilities akin to the AGM-114 Hellfire, AGM-176 Griffin, Joint Air-to-Ground Missile, and GBEU-53, BSDB-2. In November 2014, Bell Boeing conducted self-funded weapons tests, equipping a V-22 with a pylon on the front fuselage and replacing the AAQ-27AEO camera with an L3 Wescam MX-15 sensor, laser designator. 26 unguided Hydra 70 rockets, 2 guided APKWS rockets, and 2 Griffin B missiles were fired over 5 flights. The USMC and USAF sought a traversable nose-mounted weapon connected to a helmet-mounted sight recoil complicated integrating a forward-facing gun. A pylon could carry 300 pounds 140 kilograms of munitions.